In imperative apps, events call event handlers, which are containers for imperative code. So in a typical Angular app, you'll have a lot of this, unfortunately, because most Angular apps are written in a very imperative style. Here's one that I have in the project I've been converting. This is the second video I'm doing on this, and I'm kind of following along an article I just wrote, and I will have a link to that in the description. Anyway, this happens when you search for movies in a movies app. It's a submit handler called onSubmit, and it checks if the form is valid. It deletes movies. These are actually search results. It fetches movies. There's some more logic in here, and then it affects 4 pieces of state. And if the form isn't valid, it brings up a toast of an error message. So this is 5 pieces of state total that it's affecting. And so here's the diagram I drew for that. We've got the submit handler being called from the template. And then in the handler, we've got 5 concerns that are all being handled in the handler. handle. Okay, so 3 of these are in the store. 1 is the URL and 1 is in the template. This is not great separation of concerns, because in order to know what a feature is, you have to refer to how it's controlled across the entire app. This is the second time many of these are being controlled in different components. And so if you try to go to the central place where a state is to figure out why it is what it is, you're not going to see anything there. You have to do right click and find all references and then navigate through that. And yeah, so it really is a bad separation of concerns, and it's annoying. So I'm going to do the same thing I did in the last video. I'm going to get rid of this event handler and refactor it to a more reactive data flow. The simple rule to follow for reactivity is to not write callbacks, basically, because callback functions are containers of imperative code. But really the main principle to focus on is that, in Angular at least, from the template, you only make the most minimal change possible to something in TypeScript, and then everything should be downstream from that. Actually, in general, with reactive code, everything should be reactive that can be reactive, which means you're going to take like this diagram here, you're going to try to narrow it as much as possible and have everything be reactive, reacting to something else if possible. And this is where the general advice in Redux came. This is where it came from, to not put duplicate state or derived state in the store, because it should be downstream if possible. And I don't think people really realize that Flux and Redux were invented, not React, but Flux and Redux were invented for reactivity, reactive state management. Unidirectional means reactive. So a lot of the things that you hear about good state management practices really are just trying to get to this. Things that can be reactive should be reactive. This reuses logic. So if something is updating the search observable, these things will automatically update. And so that one update that happened, you don't have to duplicate that logic in 1,500 different controllers or callback functions. You just have that update logic in one place, and then everything reacts. So you're reusing like the control logic. And the benefit of this is that another benefit is that every single piece is concerned with itself. And so that's literally what it means to be declarative. Its declaration is complete. It controls itself completely. It controls its own destiny. So that also means that everything about that piece of state, its behavior over time, anything that happens to it is determined by itself, and it's all located in one place. So you can see everything else that's affecting it while you implement a new feature. And so there's like a symmetry between imperative and reactive programming. With imperative, you have a callback function that's affecting state. With reactive programming, you have state that's affected by a lot of events. So in one case, it's organized by when the code executes. In a callback function, it's all at the same time, except you've got like, especially in this callback function, you have a subscribe, and so you have asynchronous stuff there. So that's not even exactly correct. But the other one is organized by what it pertains to, what it's relevant to. And so you're going to get more context when you're working on the features here. But you have to kind of temporarily switch over to the other mindset when you're integrating a new feature. You have to think, okay, I need to add a button. And now you need to fully switch over to the context of every feature that it's going to implement. But then that forces you to take in the whole context of each of those features when you're integrating the new behavior. And that actually is what prevents the bugs. Because if you're adding a new situation, let's say like the message count, the traditional Facebook example, the message counter, the unseen message counter, if it's not behaving correctly, then it's because something from out of context updated in a naive way. And so it doesn't have all the logic in one place. So it's easy to be naive about, oh, I just need to increment it or decrement it or something, not realizing that something somewhere else was already taking care of that or stuff like that. So once the drawback, like reactive code, it forces you to focus on the state itself, and that reduces bugs. So it's a great idea. So let's see how we do it for this component. First thing is to create a search subject to represent the submission of the form, the search form. I could have just called this submit, but I didn't feel like it. Search is really what it is. I like this. So what I did here is I added context to the payload though. So when I call it, I pass in if the form is valid, and I pass in the value of the search field. This is because the original event handler right here, it was referring to these things. And so this wasn't a pure function. I mean, it's not even close to a pure function, but this specifically made it not a pure function. And that makes it less flexible. You can't copy and paste this over to a service because this is local state. It's tied to the component. So this is another reason why lately I've changed my mind a little bit about colocation and components and services. It kind of doesn't matter where you put things, because if you organize things reactively, everything you need is self-contained. And so you can move it around as long as its dependencies are moved too, which should be few, then it's easy to move around. So yeah, it's just crazy how much incrementally my mindset has changed over time. It's just like drastically different from like 5 years ago. Anyway, this is a common pattern to include event context when dispatching an event. And this makes it more portable, like I was talking about, because the value goes in the stream itself. And so you can take that stream anywhere and it will have the value. So that's nice. But another thing is, this is the answer to a problem that a lot of people have with Redux and NgRx. And it's because it's reactive, actually. The unidirectionality of it is what causes this. Because state is mostly independent and it cares about the actions. So it's reacting to events, basically. But what if you need to react in such a way that depends on state from somewhere completely different? This is a problem that a lot of people they circumvent the issue and do the lazy thing. They're like, oh, let's make meta reducers. Let's just not have this problem. Let's not really think through it. Let's just destroy this problem. Let's just go through it. Let's not think about anything. But anyway, but I think that the best solution is actually to provide context with events. There's no problem with that. Like the entire event is kind of context anyway. Something happened. Like everything you say about it is context. So this is convenient in Angular. Like sometimes you'll need to like do an async pipe on like I don't know, an ng container, and just define a local variable just so that you can pass it in with the event context. I think that's totally fine. It's like drawing the arrows around where things are going. It's a little annoying, but this is totally possible and easy, and it's fine. Events have context, and that's totally great. All right, so what's next? We have the subject with the context. Now we have to affect two pieces of state. One is the URL, and the other is invalid toast, and it just depends on whether it's valid or not. And while I was working on this, I realized that it was actually a little inconvenient the way I implemented the URL wrapper last time, the app navigate component. I had like a URL or a to property input that would have the URL that you want to go to, and then you'd pass an observable when it emits. That's when it would navigate. But that's kind of like an imperative thing. I think I mentioned this last time, but it's actually better to think of that component in the template as defining the URL in its current state. So something more reactive would be app navigate URL equals observable of URL. So that'd be more reactive. And so I actually refactored it, and let me show you what the other component, the first component from the last video, what it turned into. Here it is. Instead of just emitting something, it just maps it to the URL. That was super easy to do. So I'm glad I did this. I added an extra line of code, but it makes it more clear and it makes it more like explicit state and less like these, like observable streams that are doing mysterious things. And the implementation changed. It simplified quite a bit. It used to be 40 lines of code, now it's 23. Just use NgOnChanges instead of these observable things with the streams and weird stuff. It's actually importing nothing from RxJS anymore, and nothing in the template. It's not using the async pipe. So yeah, it's just basically really simple. NgOnChanges, watch for the URL to change. When it changes, navigate. So it just syncs the URL passed in with it syncs the router's URL with the URL passed in. So yeah, I like this better. So back to the new component. So we have this search subject with the valid and value in its context tuple there. And then we've got search is invalid, which just maps and takes the valid state from the first element in the array and returns the opposite of that. And then then there's a URL definition, and this defines what the URL should be at any given time. And this is what gets passed into the wrapper, as you can see down there at the bottom. URL equals URL $async. So it just filters by whether it's valid and then maps to what it should be using the search query string if it is valid. So that's pretty awesome. One thing I'm thinking about lately is Marco. And Marco 6, is it Marco 6 or Marco 5? I don't remember. I think Marco 6 is the new shiny one that's not out yet. That, I forgot his name. Piercy? I can't remember. He said it was taking longer than he thought it would. But I am wondering about collocation. Would it be so bad? Because with declarative programming, you get things that are self-contained. So this literally affects nothing except for this. So would it be so bad if this just was put right here in line somehow? If we just defined this right in here? Anyway, that's just something I was thinking about. Anyway, so with that done, we are feeding that into the URL, and I found out that the header is actually, what it actually means is the search string itself. Don't know why it's called header, but now it's part of the URL, so this kind of condenses, but I didn't show that in the graph, but whatever. So anyway, now we figure out the toast thing. So what we need to do is create a wrapper component like we did for the navigate method. Here's my first attempt at that. Basically simple. On changes, just if it's show, and if there's a current value, then call that swal function. This actually is sweet alerts. So this isn't actually a toast. This is a dialog. So I didn't realize that before, but that's what it is. But it doesn't make a difference because you have an imperative API and we're just wrapping it with a declarative one. But this is actually naive because once again, this was sort of event driven instead of managing it like explicit state. There was a bug that would occur where you click on or you submit a search that's invalid and it would show the dialog and it would say, hey, you suck, but in Spanish, so I don't actually know if it said that. And then you close it and then you submit a bad search again and it doesn't show up because this never changed. It was still an invalid search. So this was never called and no new alert was shown. So right here, I was like, do I pass in an observable again and do what I did with the old app navigate component? No, I learned from that. So I have to manage this as state. Well, first I tried to duct tape it. I tried to think like, okay, what if I pass in a false immediately after every true? But then that didn't trigger it because change detection, it happened synchronously because I was using a from operator from RxJS, and that meant that the dialog just wouldn't open. And then I tried to rewrite it with like a merge between two streams, and one is delayed of the first one, and then mapped to the false after a second. And it got so much code, got to become so much code. I was like, you know what? I'm just gonna Google this. No, not Google. I just clicked to the definition. Thank goodness for TypeScript. It's awesome. And I looked at the API for this. It returns a promise. So all I did was change it to allow. First of all, this is how it used to be used. Just pass in the options and then whether it's invalid, show it. But then I changed it to have an output and to push to that when the dialog is closed. So how do we use this now? Well, we had an observable from the beginning that was going to emit whenever it should show. Okay. Now we need to have an actual piece of state that always represents whether the dialog is open or closed. So when we close it, we want to set that state to false. And then we want this final observable to represent all of that. So this observable still needs to be what it is. All it is something that emits when an invalid submission happened. But we need to now feed that into a store basically, because this is now state. And so we could do like a merge or combine latest. I don't know. Not combine latest because it matters like that this event happened and not that it. So this latest value doesn't matter. What it just did matters. So it needs to trigger new behavior even if the value is the same. So that combine latest doesn't work. Honestly, just the solution popped in my head to use state adapt. It just popped in my head. I didn't really think too long. I was like, this is a thing for state adapt. So Rx Angular also allows you to react to observables and set state, but state adapt I think is slightly easier. And the whole point of this was me converting to full reactivity with state adapt too. So it was pretty obvious that I should use state adapt for this. First, I just need to provide it, the store, the provider. I never really got the point of everything being a module. Why does everything need to be a module? I don't know. This is a provider though. And then it allows you to use the adapt function, which uses inject internally. So here's the observable we had before, except I added this on it to make it an official source. So this annotation is what will show up in Redux DevTools. And then adapt takes in the path for Redux DevTools for this state, initial state, and then I imported the Boolean adapter, which is something that I export from stateadapt/core/adapters. And for some reason, TypeScript isn't auto-importing this for me, so it's really annoying. But anyway, Boolean adapter is awesome. Anyway, so this second argument, technically, it's definitely not third. This controls the state, the store in the state, or the state in the store, whichever. And so when it emits, it's going to emit false or true. Right, true, because this is invalid alert open. So when this emits, it's going to be true, and that's going to make the dialog open true. Okay, this also allows you to directly call a method on it called setFalse, because it's using the Boolean adapter. That's one of the state changes that comes with it by default. And you might think, oh, this is imperative, but you know what? No matter what we're going to do, we're going to have to set something imperative here. So what I call this is a default source. Actually, I call it synthetic source, but I kind of want to rename it to default source. Synthetic sounds too scientific. So, but default is, it comes from the adapter itself. And so if we're going to push something imperative somewhere first, no matter what, might as well just have it be defined inside here since it's not used anywhere else. If multiple features become interested in this, we could then break it out of this store and define it as an independent source and then reference it here in this store and in the other store, and then both would react. So it's as reactive as possible, but also as minimal as possible. So anyway, this works, and let me show you that in Redux DevTools. This is actually pretty neat. So let's search. Actually, we need an error, so I'll just search nothing. Incorrecto. Great. But see the Redux DevTools? It's not zoomed in super much, but yeah. setFalse, that happened when it was closed, and that came from that. So this is the action type that shows up in Redux DevTools. And you can see that it changed the invalid alert open from true to false. Isn't that nice that this represents what you actually saw on the screen? I like state management. It is nice. Anyway, how funny is it that the first thing in this entire app that is tracked in Redux DevTools is this stupid alert that wasn't even real state before? I think that's funny. All right, that's done. Now we need to move on to the next stuff. So we are changing the URL and we are opening the toast. But what needs to also happen is 3 other effects, and that is all done in the store. So since what's being controlled is the store, we should do this in the store file itself. All right. So first thing I did was split up some stuff I had before. I had this filter in this observable before. So last time we needed an observable of when the route changed from movie detail to home. So we listened to navigation end events, and we got that stream. We defined it. Okay. So I just this time split out this part, the URL after nav, and because it needs to be used in the search route. So what we need to do is, in order to define the results, we need to grab the search from the URL and pass it into the movie service and have it return results for us. So what we need is the search route first. Okay? But you may have noticed with this that something changed, because at the very top, hopefully that didn't give you a seizure or something, but anyway, at the very top, we have all these things being changed in sequence, and I mean everything's still in sequence, but the URL is now going to be changed first, and these are downstream from the URL. But it turns out that the URL, that this had to be changed before the URL, but not really. All that needed to happen, I just looked in the component and set a console log. It turned out that we just needed to, for some reason the component was redirecting out of it if one of these was set to false. And I have a feeling that this is kind of derived or duplicate state, and it kind of doesn't make sense how it's wired up, that some of this should be downstream from other parts of it. But I didn't worry about that. All I need to do is make sure that immediately upon navigation that these get set, instead of in the subscribe for the observer or after the results return. So these should chain off of this, not the results being returned. So I just added that to the list of things that can cause these state reactions to happen. So both two things need to change. We need to delete movies, which actually means clear search results. And we needed to toggle or set the flag, the search flag to false. True. And see, this seems redundant. This should be the URL, right? I think, but I'm not really like trying to refactor more than I need to here. I just want it to be, well, this is the type of thing I would refactor, but I'm not doing it now. I'm going to do it later maybe. But anyway, so this is a function that I went over last time, but it's the React function. It comes with my reactive utility wrapper class I made for NgRx component store, and you can refer to the last video for a link to the article and the article for a link to that source code. Anyway, so, but basically, I explained in the last video, but left-hand side, this specifies the method on the store that will be called when the observable emits from the right-hand side. And then it'll pass the value that's emitted from these observables into the method that's called. So I use merge because it needs to just be one observable. And so basically you have both of these. If either of these happen, search results get cleared. And this takes no parameter, so undefined, I guess, map to undefined works. So anyway, so I'm thinking about this now. I thought in the last video that maybe this wouldn't be the only route change that should cause this to happen, and I think I'm right, but who knows? Who knows? Because you're actually going to the search route in this one. But anyway, that's not the point. I just added these to things that can cause these state changes. So it's pretty cool. Things that can cause these state changes are in one place now. So now the hard part, getting the results. Well, it's the hard part of this thing, this chunk of work. All right, so you grab the search route, and what I did was I just switch map to the request to get the results, and I used a split to grab the part. So this splits into an array of an empty string and then the query string after this. And then there's a TypeScript issue that this API had, this service, so I fixed that. Anyway, so I returned the results there. And then this was some logic I hid earlier, but it was like immutable, or it was mutating stuff before with inside of for each. Now it's just mapping immutably, so that's nice. But anyway, so we got this observable of the search results. And now we can just plug it in. Save, should be called save search results. But anyway, it passes in the results from that observable. All right, so everything works again, and here's the final commit. Ooh, look at that. Is there a way to close this? Yes, there is a way. Okay. All right, so I'll just scroll through this. I'm going to walk through this, so this doesn't really matter, but yeah. All right. So personally, my main takeaway is this, that I shouldn't try to do duct tape, that I shouldn't try to pass observables and do something semi-reactive. I should just go full reactivity, full explicit state, and make these wrapper components completely declarative. Like this is this, like the inputs specify how things are, and there's no like trickery under the hood. It's just very simple. The inputs describe the current state of things. Okay, so that's what I basically took away from this. And yeah, I'm not sure how much I'm going to reuse this component, the Sweet Alerts wrapper component, but I have it now, so I can. Anyway, but yeah, it does take a little work to get these to work. You got to go the full, full reactive route. But once you do, you get rid of imperative statements. So that's nice. So this was 11 imperative statements before, and now it's only, wow, that is a major, why is that such a major difference in size? That is ridiculous. Doesn't matter. Anyway, so you can see a bunch of concerns kind of scattered around and mixed a little bit. And then now everything is completely separate and grouped by what it affects. And like I was talking about earlier, this includes effects from before. So now things that were in two separate components completely, they're both here in the same place. So before you would have had to do switch, or no, you would have clicked on this switch flag and done find all references. And then you'd look at both components. Now you look here and you can see, oh, switch flag happens when search route emits or when the URL goes from movie detail to home. Another thing to notice here in these screenshots is I'm not showing you all the code I just wrote. I'm only showing you the code that affects the state. And the reason is because you don't need to actually see the other code unless you're interested in the details. But here you have a full description of what is happening. Save search will happen when search results emits. So this is already completely declarative, and the co-location is maximized here. You don't have to have all the details in here. Just like if you're calculating x equals y plus 2, you don't need the definition of what plus is in line in that statement. You have symbols that reference ideas, and you know, if you understand those symbols, you understand exactly what's happening. So nothing's being hidden from you, and you can just click to definition to see more detail if you're interested. So the actual control logic of what changes when, that is stated explicitly right here. This is completely declarative. It is complete. It's a complete description of what happens. And the details you can find by clicking on it and going to the definition. But at least you have that description in one place. On the other hand, in an imperative project, the only way to know everything that will affect something is to click on find all references and go all the way around, all the results, and navigate around and look at every single callback function. And then you have to learn the context, most of which will be irrelevant to the current thing you're doing. And it'll come with its own baggage, and it's like mixed concerns that you have to go and sift through. Not only that, but this function name doesn't actually tell you much. Imagine calling it from the template. You have click equals on submit or submit equals on submit. Like, that is the most useless function name in history. And yet this is what you see in most Angular projects. And why is that? Because functions should be named for what they do. But look at all the stuff this function's doing. It's doing all kinds of stuff. And so you name it for the commonality among all of its effects. And what's that commonality? Basically nothing. And so you, instead of having good function names according to like the clean code book, and just like according to have textbook clean code function names. Man, that was such a disaster of a sentence that I lost my train of thought. Okay, so textbook clean code function names are named for what they do, not for who calls them or where they're called or why they're called. They're just named for what they do because a function does something. That's what it is. And so the fact that the most common function name you see is, oh, this is onClick. What do you mean it's onClick? That's not what it's doing. That's not a good function name. You see an event handler named for the event that's calling it. But if you look at the template, you just see click equals onClick. Great. I'm glad to know, that's a useless function name. But that's the best we can do because there's nothing specific that all these share in common. Validate? No, that's only this part and that part. Fetching result? No, that doesn't happen if it's the only common thing is this happens when you submit. And it's all kinds of stuff. So, if you try really hard, you can come up with something very, very abstract that isn't submit, but a little more specific. But that takes so much time, nobody does it. So, yeah. good names come easily with declarative programming because you know what this thing is? This is a URL. It's not concerned with anything else. It's just a URL. And maybe it changes over time, but it's still a URL. So that is so simple. Everything is self-contained and self-describing. And this pattern, it just permeates the entire code base. You're never going to struggle to come up with some stupid function name that does 5 things and try to figure out, okay, what is the essence of what this function's doing? Like, what is it really doing? And it's like, okay, but it also has this weird side effect that, screw it, we'll just name it on mouse over or something. Okay, so I kind of felt like a rant, but it wasn't really rant. It was just something I'm excited about right now. This clear understanding that I have just kind of developed. I never really connected those dots until just now, actually. The function names being named for what they do, and that never being the case with event handlers. So, yeah. Anyway, so as far as lines of code go, it kind of sucks because here's an example. This nice little dialog that we just called a function out into the void and all these, just magically appeared. It's now being controlled with state. So this was 6 lines of code. It changed to 8 here and another 10 here. So this was 18 lines of code and used to be just 6 lines of code. And that's actually most of the difference. But there were other places that got bigger too. So it was 79 insertions, 62 deletions. So I'm starting to doubt that this will actually be more minimal in the end, but I don't care. It's way cleaner, way easier to understand, and more, good separation of concerns. I am excited to see the end of this, even though it's a random project on GitHub. I do get emotionally attached to every project I work on, even if it is just some random thing that has basically no value except to the person who originally created it. But anyway, we still have a couple components left that have interesting imperative patterns going on that we can refactor. And then this project will be done and we can analyze it then. I also think it'd be cool. Check this out. Hang on. People like diagrams, right? I like diagrams. Anyway, so I have diagrams from everything I've done so far. 2 whole components. And there are going to be 2 or 3 more sets of these. But these are all for the component I just did. These are for the component I did last time. And there are 3 each because this is the one I thought I would do. And then this is one I optimized for making as much downstream as possible in both cases. So here's a cool thing I could do. Even though I wasn't consistent with the colors, I could join them all up together. Why not? Because then you could really see the benefit, because there would be this box here, and then all these circles would join up together. But over here, it's already like these are like, these would be the exact same circles. Let's see, where's the flag? The blue goes to the orange there. Anyway, so I'd figure out the color scheme. I think I'm going to keep this one because I did more work for this and this. This would be easy to change. But anyway, I think it'd be fun to connect an entire graph and just go through, kind of just float around the whole graph and just look at, oh, this used to be this, now it's this, and show visually how centralized the control logic became, and that would just be really cool. So anyway, if you're interested in that, subscribe to my channel. All right, thanks for watching. Bye.